In hospitals with numerous wards and high sending frequencies, a rapid direct transport between the sender and the recipient is important. Depending on the transport requirements, systems can be split into several lines, each simultaneously capable of transporting carriers. A multi-line distribution unit connects the individual lines into a network. Line distribution units are a well-proven system. Carriers are forwarded centrally from one line to another. AB distribution units ensure a fast and reliable communication between two lines. This solution makes it possible to implement two-line systems. Both lines can each transport carriers independently of each other, whereby the lines are connected with each other via storage positions, making dispatching from and to every station possible. Due to the storage positions, carriers approaching from opposite directions do not interfere with each other. Waiting times are minimized and the transfer frequency is optimized. Depending on the number of lines, this system is upgradable as desired. Upgrading to 3 lines by adding 1 would produce even more transport performance, since every line can transport 1 carrier each and thus a total of 3 simultaneously. And for especially efficient systems with direct connections between all lines. Power transfer is the latest development in the area of multi-line pneumatic tube systems. This line distribution unit unites highly functional high-performance technology with a sophisticated compact design. Power transfer comprises of a large number of carrier storage positions, which are flexibly driven at high speeds in both directions and accelerated and slowed down gently, which is important for sensitive loads such as laboratory samples. A number of storage positions always remains reserved for such high priority sendings as, for example, emergency samples, which guarantees that these can be passed on immediately and therefore overtake the carriers dispatched ahead of them. Carrier storage positions can also be used as storage for empty carriers. If no empty carriers are available at a station, the user can call an empty carrier from the power transfer. One further convincing advantage of power transfer is the maximum transfer capacity. Carriers can be received simultaneously and sent on over the shortest route using the two-way mode. Whether a line distribution unit or the high-performance power transfer, Sumetzberger's solutions provide for unrivaled transport times in every pneumatic tube system, even over long distances, and significantly increase the system's efficiency. The growing quality and performance pressure in the hospital sector leads to an increasing demand for efficient, reliable pneumatic tube system solutions capable of processing large amounts of carriers even during peak times. Sumetzberger's multi-carrier transport more than complies with the high safety and frequency standards. Several carriers can be transported through one line simultaneously with minimal space and equipment requirements. The carriers can be sent consecutively to a multi-receiving station via a line distribution unit or a power transfer. Upon arrival, the carriers are gently ejected one by one. Up to 8 carriers can be transported through one line. The same principle applies when empty carriers are returned. They are placed into the station's dispatch magazine and subsequently sent back to their station of origin completely automatically. The multi-carrier transport can also act as a high-performance connection between 2 power transfers. Several carriers can be sent from one power transfer to another simultaneously, even over long distances, and with minimal tube and space requirements. Whether in laboratories or between line distribution units, wherever high transfer frequencies occur, the dispatch traffic must run smoothly and efficiently. With the multi-carrier transport, Sumetzberger offers the possibility to simultaneously transport numerous carriers with less tube installation and space requirements through one line, and thus provide for the capacity required to handle possible transfer peaks.